So we've got bones, we've got joints. What else do we need, right? Well, we need something to hold everything together. So we're going to talk about connective tissue. And in chapter 3, we're going to talk about muscles. So muscles, of course, have that motion function, moving things and moving those bony levers. They also do have some structural function holding things together. And connective tissues, that's their job, to hold everything together. So that's why I say functional considerations, because form follows function. We have these different things because they do something. So we're going to talk about the form, and we're going to talk about the function and the composition. So for the learning objectives, I want you to be able to explain how ligaments and tendons support joint structure. Very important, right? Or you'll end up like my little skeleton here with a bunch of nuts and bolts to hold you together. And let's talk about the effects of immobilization on connective tissue. This is something that we encounter in physical therapy all the time, so we need to talk about it. So connective tissues, all of our connective tissues supporting the joints of the body are composed of different fibers like collagen and elastin, ground substance, and we'll talk about what the ground substance is, and then cells. So you need cells to create the collagen and create the ground substance. So the cells are important. So these are all biological materials that are blended in various proportions on the basis of the joint's mechanical demands. So some of our connective tissues are more elastic, some of them are more rigid, depending on what the joint needs. So form follows function, right? If we need something where we need super rigid support, we're going to have a different blend of materials than something where we need more flexible support. Like the synovial joint capsule, that's made of connective tissue. It needs to be flexible so we can actually bend the joint, right? So there are different types of fibers that are involved in connective tissue. We have two different types of collagen fibers, type 1 and type 2. There are other types of collagen, and we'll talk more about this in upcoming classes. But for now, we're going to talk about type 1 and type 2. So type 1 collagen fibers are thick, hefty fibers that resist elongation. Ligaments, tendons, and fibrous joint capsules are type 1 collagen fibers because they need to be there for you. They need to hold that joint together. They need to keep your knee from hyperextending. They need to glue everything together, basically. Type 2 collagen fibers are thinner and less stiff than type 1 fibers. They often provide a flexible woven framework for maintaining the general shape and consistency of structures. So we have a lot of fibrous connective tissue in our body that holds everything together. In the joint capsule lecture, there was a cadaver picture that showed the synovial joint capsule, and you saw that webbing of connective tissue that was around the joint. So a lot of that is composed of type 2 collagen fibers. Elastin, as you can probably guess by its name, it's elastic. It resists tensile forces, but it has a little more give when you elongate it. A lot of times it is in tissues that help to prevent injury because they allow the tissue to bend but not break. So elastin is in a lot of our connective tissues, and the proportion of the different types of collagen and elastin are going to determine the properties of the individual tissues. So the ground substance is primarily composed of glycosaminoglycans, or GAGs, water, and then dissolved chemicals, so solutes. Water is the solution, and their dissolved chemicals are the solutes. The ground substance allows body fibers to exist in a fluid-filled environment, and it disperses repetitive forces. So as we get older, our ground substance becomes more dehydrated, and so we're more prone to connective tissue injuries like sprains, rotator cuff tears, that sort of thing. So when our ground substance has less water in it, it is less able to disperse repetitive forces. The cells that exist in our connective tissue are the ones that are responsible for the maintenance and repair of tissues that constitute joints. So they're things like fibroblasts and osteoclasts and osteoblasts. So fibroblasts are spitting out collagen and they're spitting out other stuff too. So we have to have those cells in order to create the materials that make up our connective tissue. So the four basic types of connective tissue that form the structure of joints are dense, irregular connective tissue, articular cartilage, fibrocartilage, and bone. And yes, bone is considered a connective tissue, but it has other specialized functions as well. So we do have other types of connective tissue that we will talk about in other classes when we talk about soft tissue mobilization in the fall. We will drill down a little bit more on some of our different types of connective tissues, but for our purposes right now, these are the ones we're going to talk about. So dense, irregular connective tissue binds bones together and restrains unwanted movement of joints. That's nice, right? So ligaments and joint capsules are often made of the dense, irregular connective tissue. They're primarily type 1 collagen, the tough kind, and low elastin because we want strength and not stretch. So low elastin content in dense, irregular connective tissue. Articular cartilage resists and distributes compressive and shear forces transmitted through articular surfaces. Remember when we talked about the three different types of arthrokinematic movements, the roll, spin, and glide. So there's lots of shear forces. Roll, spin, and slide. I said glide, I meant slide. So we get shear forces and we get rolling forces and we get spinning forces. So we need a tough surface in order for those joint movements to go on. Articular cartilage covers the end of articulating bones in synovial joints. It is high type 2 collagen fiber content, and it helps anchor the cartilage to the bone. So the other thing we talked about, the periosteum on the long bones, the periosteum also provides attachment places for ligaments and joints, or ligaments and tendons and other connective tissue. So we're not just bolting it onto the bone, we have to have something to connect to, and the periosteum is where it connects onto bones. And a lot of times when you see little irregular surfaces on the bone, like the greater trochanter, the lesser trochanter, the epicondyles, that sort of thing, where there's a little bump, often that is the attachment point of a muscle, but it attaches through the tendon to the periosteum on the bone. Fibrocartilage provides support and stabilization to joints, shock absorption. So think of fibrocartilage as being shock absorption. It resists and disperses compressive and shear forces. The intervertebral discs and the menisci of the knee, the articular, the fibrocartilage that's in the pubis between the two sides of the pubic bone, it has to move and provide shock absorption and disperse shear forces. So we get multi-directional bundles of type 1 collagen. So it's tough and there's a lot of it. And it's multi-directional because it has to absorb and disperse forces from lots of different directions. So bone, of course, forms the primary supporting structure of the body and provides a rigid lever to transmit muscle force to move and stabilize the body. Bone forms the internal levers of the musculoskeletal system. So bone is a specialized arrangement of type 1 collagen, providing a framework for the hard mineral salts that make up the hardness of the bone. So we have a lot of calcium and phosphorus in our bones, but we need that collagen framework in order to make the bones a little less brittle, a little more reactive. So the collagen framework is really important in bone. It provides a matrix in which those minerals can be formed. So for tendons and ligaments, the fibrous composition of tendons and ligaments is similar, but the arrangement of the fibers and the function of the two different types of connective tissue differ significantly. So tendons connect muscle to bone. They convert muscular force into bony motion. And so it's very important that you have that parallel alignment of collagen fibers, because you're directly transmitting the force with the parallel alignment. With ligaments, the alignment is a little more irregular. We're connecting bone to bone. We're trying to maintain a joint structure. We're trying to restrict movements. And so we have that irregular crossing pattern of collagen fibers, so you can absorb forces in different directions. So the tendon is transmitting the force in one direction. Ligaments are absorbing forces in different directions. So that's why you need that irregular crossing pattern of collagen fibers. When we talk about individual ligaments in the joints, we're going to talk about them in terms of what motion do they prevent. So ligaments' job is to prevent motion. Tendon's job is to transmit motion. So we also have muscle for active joint stabilization. It's not just passive the way a ligament is. So our bony conformation and our ligament networks provide static stability, and muscles function as active stabilizers. So muscles can't respond as quickly as ligaments to external force. So with a ligament, there's an external force and the ligament's like, nope, I don't think so. I don't think so. But muscles allow a more graded and controlled response. They can say, okay, we got this under control. We've got a little motion, but we're controlling it with our nervous system. It can be done. So when we immobilize connective tissues, it increases stiffness and it decreases the tissue's ability to withstand forces. That's important. Immobilization might be necessary in the case of a fracture or injury of some sort, but it makes joints more susceptible to injury and instability. So it's a lot of times it's like protected mobilization. The immobilization is important to protect the injury site, but we also have to have a relatively quick return to weight bearing and usually specific strengthening exercises in order to rehabilitate a joint injury or a ligament or tendon or muscle injury. So immobilization might be necessary early on, but we really want to return to protective weight bearing so we can strengthen those structures as well. So each joint has different functional capabilities, and we're going to go through the body joint by joint, major joint by major joint, and talk about those specific functional capabilities. The range of motion and relative stability of a joint depend on its bony structure, the muscles that are surrounding it, and connective tissues. So there's a lot going on in each joint. There's always a trade-off between stability and mobility. A joint that is hypermobile is less stable. A joint that's super stable is less mobile. So it's the trade-off. And when we talk about a lot of things we'll talk about in physical therapy have to do with that spectrum from stability to mobility. Where are we on that spectrum? So when you look at the shoulder joint, it is a very mobile joint, and therefore it is a less stable joint than a lot of our other joints. Good thing we don't have to walk around on our hands, right? That'd be difficult. Boy, think of the rehab issues we'd run into with that. So every joint in the body has to find that balance between mobility and stability in order to function properly. And when that gets out of balance, a lot of times they have to come to us to help restore the balance.